Hello and welcome to Eco Show number 3, a show about eco-related things from research to happenings in the environment and in the world, and I stray off that a bit as well. So this is number 3, and we'll hop. And I'm Henry. I don't know if I said that. I'm Henry, and I am doing this show right now. But I also am doing a PhD in ecology-related things. So I got the credentials. Anyways. Okay, so today, hopping right into it, in popular news, we had the big weather situation out in the United States, in California, what was being called an atmospheric river. And so there was a research article by Thomas Corringham et al. And I wanted to bring this up because they were looking at potential costs of increased flooding related to issues that came up from the storm, and their findings are big increases in costs due to climate change from $1 billion to $3 billion. And just some information about what this atmospheric river is this really long weather system that is hundreds of miles or kilometers wide and can be thousands of kilometers long. So I've got an image up here that's showing what's called the Pineapple Express, and that's reaching all the way across the Pacific Ocean. So it's this big movement of moisture. And in California, or in the West Coast, 84% of total flood damage in the past 40 years has been due to this weather system. And the good side, well, not the good side about it, but what this research was doing is looking at what areas are most likely to be hit to be able to make good predictions for where to adapt in these areas to climate change. And one of the thoughts that I always have when you have these big flooding events, especially in areas that have so much drought, is that it's surprising to me how much of that just goes into storm drains and goes out to sea. You'd think there would be some way to save that water, or at least keep it in a river or something like that. So there you go. There's some popular news about atmospheric rivers. And we're moving on now to some other research looking to the journal Nature Plantz. So Nature is a big publication of journals, and they have lots of mini versions of itself. So they've got Nature Plantz, which is what we're looking at today. And so this article was by D'Angelo et al. Should have had the first names on this one, and I'll get to the title in a second. But the motivation behind this is that there are these net zero carbon emission targets that lots of countries are having, so they're wanting to be drawing down more carbon than they're releasing, essentially. And what this article was looking at is what would be the ability of seaweed farming to impact carbon sequestration. And it hasn't really been explored before, but seaweed farming is a large industry. There should be a little image of a little seaweed crop being grown. And so the ability to grow seaweed requires really specific growing conditions. And what they did was they made a techno-economic model to estimate the cost of global seaweed production and the related climate benefits. And an assumption made in this was that phytoplankton are not going to be impacted, but they already likely use a lot of carbon dioxide. So phytoplankton are like the little guy in SpongeBob. Well, he's plankton. He's kind of green. But anyways, phytoplankton is a very tiny sea creature that uses photosynthesis to get its energy, and it uses carbon dioxide in the water. I feel like I said something wrong there, but I think that's all correct. But so they're little sea creatures. They're out there in the ocean, and they photosynthesize a lot. So they're already taking a lot of carbon dioxide that's in the water, because carbon dioxide is in our atmosphere and it also goes into the ocean. And they already use a lot of that. So sometimes when they're looking at this ocean production of seaweed, is they're saying, well, by producing seaweed, are they possibly taking away carbon dioxide from phytoplankton? But they've removed that from the model. So what they were looking at is that to have an impact, a real impact on carbon sequestration, they would need to be over areas greater than 90,000 square kilometers. So that's a huge amount of area. If we're thinking about a 3,000 by 300 by 300, well, actually, it's a big area. So, and that's a 30-fold increase in the current area that's being farmed for seaweed already. So what they're saying essentially is that to really have a big positive impact from seaweed farming, you would need to increase the area where seaweed is grown by a huge amount. And those areas are pretty specific in terms of, like you can see in this image, it's the bottom is flat and it's not too far from the surface, because as you get further down, you get less light going in there. Okay. We're in nature plants, and there's a little bit of a crop vibe to today's thing. So I hope you like plants, because you're getting some more plants. But it's an interesting thing, thinking about seaweed, but agricultural production of seaweed, we don't think about that much. Okay. Next article is, I think I can read the title of this one, and it doesn't matter them. Okay, and the title of the last one was Economic and Biophysical Limits to Seaweed Farming for Climate Change Mitigation. Okay, this article, I did put the first name, Aaron Davis et al. Has put together this article that we're talking about now. And we're talking about coffee, and in particular about the re-emergence of Liberica coffee as a major crop plant. So coffee supplies rely mostly on Arabica and Robusta coffee plants. So Arabica is around 55% and Robusta is around 45% of coffee production. And which one is the one? I didn't put it in there, but I believe Robusta is one that's used more in instant coffees, and the flavor tends to be considered not as good as Arabica, but it's usually used in blends with Arabica coffees a lot. So in 2021 and 2022, there were big shortfalls in Arabica and Robusta coffees and big price increases. So there was a doubling in price of Arabica coffees. And one of these deficits was due to a big frost that happened in Brazil, and there was a loss of 80,000 trees. So one frost, boom, lost a whole bunch of trees, prices go up. And climate change is predicting a decline in yield and suitable climatic conditions. So coffee tends to need specific climatic conditions in order to grow. And this is a big multi-billion-dollar market that's of concern to people. So the options for climate change for coffee are relocation to suitable growing areas, which are decreasing, and adaptation of practices, or developing new coffee products, coffee crops. And 3 is potentially one of the easier ones to do. And Liberica coffee is a possible option. So Liberica coffee is indigenous to tropical West and Central Africa. And it was very popular in the 1800s because in the 1800s there was a big coffee leaf rust outbreak. So there was a big decrease in coffees, but this Liberica coffee was able to hang out, and it could grow in more environments, and it had big fruit and seed, and it wouldn't fall off when it was ripe. So it was like, great, it's not just falling to the ground. But then when this disease started to get moved through, some of those things that were positive about it, having a big fruit and a big seed and not falling off when it was ripe, were actually bad because you couldn't get as much of a consistent age for the coffee seed, which is the coffee bean. So eventually it was not as popular and was moved out. But they've sort of people have been experimenting with it now, and it has these abilities to grow in a wider variety of situations. So now it's being looked at to be a new coffee crop. So buy your coffee crop stocks in Liberica. I don't know if that's not financial advice, but people are interested in that. So there you have it. There's some information on your coffee if you drink it, or some facts for people who drink that if you want to give coffee drinkers some coffee facts. And that's a lovely image of the Liberica coffee leaf that was drawn back in the day. There should be a reference for that photo next time. Okay. Oh, we're on to the next one. We're out of coffee crop land and we're into plant history. So the title and that article, I did read it. I read the title for that last one. This article, The Origin of Land Flora by John Bowman. We're still in Nature Plants, but now we're talking about the origins of land flora. Flora is just like plants, like fauna is animal things. So algae had been on land for a long time, but they weren't doing great. So this is way back in the day. And then 470 million years ago, algae, which were on land, because most of life was in the water at the time, they evolved complex multicellularity. So this was 470 million years ago. These dates change a lot with new research, but that's about what we're looking at now. And this big change resulted in the embryo fight. And the embryo fight, which we can think about because of the word embryo in there, and then fight, talking about plants, is that you had the development of the embryo in plants. And so that protected plants from desiccation as quickly as algae would have been. And around 420 million years ago, land plants started to really diversify. 200 million years ago, flowering plants came about. And when I was reading about this, surprise, surprise, grasses came about 40 million years ago. Isn't that interesting? So you had flowering plants before you had grasses, which is not something I would have thought about. And the impacts of this spread of plants across the earth was that there was decreased carbon dioxide in the atmosphere. And when carbon dioxide was taken out of the atmosphere, there was more oxygen in the atmosphere. And this caused cooling around the world. And by increasing oxygen, which is pretty corrosive, a lot of animals then started to develop pathways to use oxygen to power their energy production capabilities. And what else are we looking at? And another big thing that happened around this time, this is kind of a smorgasbord of information, but when you had the growth of a lot of these plants had something in them called lignin, which was hard to break down, substance inside of them. So a lot of these plants that were growing during this big boom of plants were then put down in the ground, and we're taking them out now and burning them. So a big cause of that decreased climate back then was because carbon was getting taken out of the atmosphere, and then it was locked into these plants in lignin and things like that, which couldn't be broken down and munched on. And a result of this was a continued cold period over a long period of time. So, Origin of a Land Flora and that article was by John Bowman. A lot of the article was focusing on the embryo site, which is an interesting thing to look into in terms of a lot of what he was talking about in this article was the particular structures within the plant cell and how that led to this ability to adapt and survive multicellularity. Okay. If I haven't lost you on that one, how are we doing? We're doing pretty good. I'm going to cruise through these next two. And we've got a lovely image of a back in the day landscape with plants. It's looking very green. Okay. Our fifth article, let's have a look-see, is by Thomas Abelli et al. And this is sort of a little, I guess, a technical article talking about out-of-date data sets and how they hamper conservation of species close to extinction. So databases are really important and helpful. It's how we understand what species are around and how many of them there are and where they are. But these big databases are often not interconnected and are updated irregularly. And there's often not common standards for these databases. And so they did a study that found that 16 species thought to be extinct are actually in a rehabilitative state. So that was a quick note, that article. Sort out your databases. If you're a database person, keep it in check. and hopefully we can get more databases interconnected. And there's no image for that one, so that was we're moving through that one. Okay, and our last article is titled Selecting the Best Candidates for Resurrecting Extinct in the Wild Plants from Herbaria. And that's by Giulia Albani Rocchetti et al. And so this is kind of a continuation on the last one about databases and what they're looking to do. And we've got an image here, a flow chart, which is looking at this decision-making process that they have for bringing back wild plants. So people talk a lot about bringing back animals. You may have been hearing about people talking about bringing back mammoths, but plants aren't talked about as much. But there's a lot of material in herbariums, which is where plant materials are stored and saved. There's a lot of plant material that can be used to bring back plants. And through their study, they found that there's a number of species that can be brought back. And since we are at a really high extinction rate now with climate change and other human impacts and things like that, extinction rate is really high at, they're saying, 1,000 times the baseline rate of extinction, which is a lot. And so understanding what can be brought back is important. And while they're saying 20 to 39% of all species are at risk of extinction globally, and prioritizing species is going to be important. So here's their flow chart for looking through things. So updating extinct species lists, searching for specimens, so seeing what's extinct. And by extinct, they're talking about extinct in the wild generally. So something might be extinct in the wild and even extinct from herbarium, but there may be plant materials that could be used to bring them back. And then looking for, once you find the specimen, see if there are seeds in the specimens, and look at these values for being able to, what is it? Dex, Go, and ED values. Okay, so I think that's talking about desiccation related. So what's the likelihood of bringing the seed back? Because you might be damaging the seed if you do decide to try and bring it back. And then you select your seed. So they're working on a system to be able to bring things back. And as things go extinct, under current conditions, figuring out what it is you need to save and how to save it going into the future will be really important. So there you have it. Those are our articles for today. I hope you have a great week, and we will catch you next time. See ya.